friends, and hello student. My name is Ashok Sijala. In this session, we learn the 2D two-dimensional array with pointer in C language. So first I share my laptop screen and here fix the position so you can watch better my video lecture. And here Turbo C++, I double click and take some time. And now just is open Alt F file menu and taking new file. And here our goal, write a program to print uh, two just two-dimensional array using pointer. Yes, that is our goal. So how many techniques? So yes, I give the eight techniques or way you can say that. So eight technique you can print 2D array using the pointer. Like in my one video lecture, one one dimensional array using pointer take the 9 techniques. So that is a very important for your knowledge. So here we can take the 8 technique, but first we can understand how you can take the 2D array pointer variable. So there are 3 techniques, means taking the address of two-dimensional array. So let us check. I first give one example. So here we can declare as a static. So that is a first 1, 2, 3. That is our first row, and second row 4, 5, and 6, and that is static initialization. So yes, that 7, 8, and 9. Yes, and then whole brace, and here we can take asterisk. That is our as pointer variable. Yes, and then semicolon. So yes, there are 3 techniques, but 8 technique we can print. But how to take the address of 2D array to pointer? So yes, first that is our like ampersand x of 00. That is a taking the base address of that is first byte element of array that known as a base address. Yes, and that or I write the or means that same. So here also second technique asterisk x that also take the base address, and then last you can say that first yes that is only row, not here we can declare as a 2D means two-dimensional array, two subscript, but you can also take the address x of 0, that is our one-dimensional array. So that is a first element also, that is 0, that taking address of first row, and here also that same, and here is also same. Yes, so there are 3 techniques we can assign to pointer variable two-dimensional array as an address. And now how internal memory there is no row and column in, that is the just we can understand. So here we can say that that is a 0 row, yes, that first, and that is index start with 0. So and that is second means index 0 and 1, then 2. So actual 3 row is there. So that is a first row. Yes, we can say that that is first row, and that is second row. So internal memory is a continuous block. We can understand row and column for our just how work 2D array. So exactly that store, like here we can give the x is our original array name, and we can store the like value 1, then I give some gap 2, and then 3, and then here 4, yes, here 5, and here 6, and some blank because we can take also address, and that 7, yes, 8, and 9, that is our 9 element 3 by 3. So 3 multiply 3, so 9 element. And here we can say that that is a first one-dimensional array. Yes, that is a one-dimensional array, or we can say that that is a 0 row. Yes, here I write the 0 row. So that is a both. So 2D array is a collection of 1D array. Yes, you have to know very well. And that is a second, you can say that 1D array. That is our second 1D array. And here we can say that third our 1D array. And that also we can say that that is a yes, I already write. So that is 0 row. Yes, that is a one row, and that is a second row. So actual three row is there. So you can also, that 2D array is a collection of 1D array, and here is a in that is a address. So we can assumption. So that is a first address, and that address known as a base address. Yes, that is a address, but the base, that first byte means first element, that address known as a uh, base address. And then 1002, because that is a integer, so that 2 byte is shifting. So I a pointer, how we can increment and decrement, how pointer jump in 2D array, I can explain to you. So that first we can understand what in how at store in 2D array internal. So that is a continuous block. Now 1004, and then 1000, here is a 6, and then 1008. Yes, here is a 8, and then here 1010. Yes, we can start 0. So 2, yes, here 4, then 6, 8, and 10. So here is a 1012. Here 1014, and last year is a 1016. Yes, so that is a store. Yes, so here that is a x means that value, and you can also specify index like 0. First row is 0, 0, 0, first row, that index, and 0, 1, 0, 0 plus 0, 1, 0, 2, that is first index. Then same, yes, here that help menu open. So yes, here then after here 1, 1, 1, first second row, because index start with 0, and 1, 0, then 1, 1, and 1, 2. Then third row 2, 0, 2, 1, 2, 2. That is index. Yes, I think you have to know very well. And then one formula. Yes, that is a here one formula. You can find the particular jump how. So yes, that we can say that formula is there. So yes, we can find like here first is a P, and that is a address of our base address store. So here we can say that like P equal to X is also possible, that store the 1000 address. Yes, and then P plus 1. Yes, so P plus 1, how many byte is shifting? So here I can say that store the directly 1006 address. Yes, how it's possible? So yes, that directly here first byte of first row, and then directly jump to second row first byte address. So how that we can get, and then P plus again I give the 1, or we can say that means 2. So we can or store the directly 1012 address. Yes, that is a last our here is a, so yes, that is a your address. So here you can look here, that is our third row starting, that is address. So how it's getting this type of so that is one formula is there. So our pointer variable equal to base address, that formula I can write. So BA plus in parenthesis we can take the index. Yes, that is index, and then we can say that multiplication scale. Yes, that is a scale, and factor FSC for scale factor means pointer jump to refer that data type, that number of byte is shifting. So we can say that scale factor of scale factor of total size of 1D array. Yes, total size of 1D array, that is a jumping. So here we can say that like P, and that our we can now write to our formula. So 1000 is our base address, and then index that we can if find. Yes, here how we can find. So here we can find the x1 and then 0. Yes, which, so which address here? Second row, and that first address, how it's find this formula. So here we can put that type of index. So here we can index first row. So that is a first, and then total number of means that is scale factor of refer to this our element. So 1D array actually three size means that is a three row and three column. So we can say that three and not zero. Yes, here is not zero. So means that we have to find this address. So that is a we can based on this syntax means formula. So base address is 1000 plus index is actually 3, and scale factor refer of the total size. So that is a multiplication. So yes, now I can solve this formula. So 1000 plus that is a 1 multiply 3. So actual 3, but here jump is a refer that scale factor, and that is directly 6 here. Why? Because scale factor of total size of array. So total size of one row is a 6 element. So that is jumping directly 6. So this index is a here. That is a index address. So we can say that 1 0, that we can find this formula. So index multiplies scale factor of total size of 1D array. So here we can give the 3, but that actual the refer that total integer data type, and then three element is stored. So that is a 6 byte is shifting. We can say that pointer jump directly 6 byte. So I here, so you can take this type of address 1000, then 1006 and 1012. So that is a first row first element, second row first element address, and third row first address element. So based on this formula we can find out to first element or any element, but first element we can refer the scale factor. So we can plus plus in 2D array. So that is a go in next 1D array. Yes, I can say it now. You have to understand 2D array is a collection of 1D array. So when we can p plus plus in 2D array, so next 2D array start that first address that taking, and next time we can plus plus. So that is second means that second 2D, or we can say the third row is 2, and that third 2D array. Yes, so that is a jumping. So pointer we can plus plus. So that 2D array one dimensional array as pass out means one row is shifting. So yes, based on this formula, I can explain to yes. And next we can individual element. Yes, that is a 1D array. Here to here we can shift them, and here to here. Now we can how find out individual address. So that formula is a difference. So I yes also I that is a paperwork I first show, and then I print 8th technique for you. So very interesting. So you can understand then very interesting point in this session. So yes, now we can take array that variable we can find particular address. Yes, so array name, yes, that is our we can say that array name is we have to take, and then we can find any value means that like here we can give the base address again. So ba, yes, then plus, and then row, yes, row number, not a row number of row, not but the row number how to pass, and then number of column, yes, number of column, and row number is different, and then yes plus again, and then column number, yes, so column number. So based on this formula we can find the any. So array variable name, so array variable name is our x, yes, that is store the base address, and we can find the any address of this formula. So here we can write that is a base address store. So any element find the address, any element address based on this formula. Yes, so let us take how it's find. So yes, let us, so I can take the address of 1, and here is a 1. Yes, so based on this formula we can find. Yes, so 1000, that is our base address. Yes, now I here write, yes, now plus, so number of row, yes, row number is 1, then multiplication sign is the internal. So number of column, total number of columns, so multiplication column, and then column number, that is also 1. So now we can solve. So yes, first we can addition means multiplication. So yes, 1 multiply 3, and that is taking the we can say that first if we 0 0 pass, so that is find the 1000, and then we can find any particular address. So based on this syntax we can find. So here you can know very well, here our jumping is a refer the scale factor. So multiplication 3 and then 4. So 4 multiplication here. So actually that is jump 1008, because that is a refer the scale factor, because that is 4 means integer data type. So 4 multiply 2, so 8 byte is shifting. Yes, actually 8 byte. So that is the address of this 5 element, that is value is 5, and that address is 1008, because that index is a 1 1, means one row with the second 1D array and second element. So we can say second row and second element, that is a meaning, and that address is 1008. So based on this formula, we can find the any value of array, 2D array, we can find that address. Yes. So that is a, I think, sufficient. So very important. So here we can find the 1D address. Yes, that formula is different. And here any element address, that formula is different. So here we can find 1 1. So that index, and we can pass that type of index. So 1 multiply 3 and plus 4. So 4, and pointer refer their scale factor. Scale factor means that refer their data types, like integer data types. So 2 byte multiplication. If a character data type, so 1 multiplication. Float, so 4 bytes is multiplication, and double, so that is 8, and long double, so 10 bytes. So that is known as a scale factor. So pointer refer their data type, and that is known as a scale factor. Okay, so that shifting or jumping that number of bytes. So yes, very interesting for you. Now I close this all, and means comment line for you, your reference, and here after we can start our example, how many 8 technique we can use also this formula. Yes, here our last formula. So yes, now I can write print our 2D array. So first we can print our as it is usual, normal, without pointer, and then we can take pointer also. So yes, you have to know now our header file and main, and here I declare to our, yeah, yes, static. Here we cannot take from user, and then we can also static value also, or same example. So yes, you can understand 1 2 3, because our goal is a how many technique to print the 1D or 2D array. 1D array is a 9, and 2D array is a 8 technique. So yes, 4 5 and 6. Yes, that is second row, and then comma 7 8 and 9, and then 2 brace. Yes, and also I take the, yes, I j, and then our asterisk pointer variable. So yes, I clear the screen, and then we can directly first print. You can also scan, that is I declare the static array. You can also take from user scan, but here we can just understand how many technique to print the 2D array with help of pointer. So yes, 2D array elements are, yes, and slash n, yes, internal, yes, it's double quotes. Okay, now for loop I equal to 0, I less than fix 3 size, and then we can take inner for loop, yes, and then here j equal to 0, j less than 3, and then j plus plus. And now we can print with index. So first our technique simple, that is a x, yes, and then subscript, and then again percentage d, because row and column 2 index, so I and j. Yes. So yes, with index we have to print. So percentage d again, and then I print x of I and j, that is a value. And then here we can take the slash n. So new row is taking the one that is a slash n. One row is finished. Yes, I save this file. So here we can say that pointer and 2D array. Yes, and dot c. So pointer to the array and maximum 8 character is there. Yes. So yes, here I cannot give slash n, but the internal we can, yes, here I give slash n, and after element one blank. So you can easily see, yes, there is no any error, and exe file, executable file is generated, and let us that directly print. Yes. So here we can take comment line. Yes. So here we can complete, and so that is all paperwork. I also board working for your reference. And here we cannot use get ch. Yes, our output is yes, Alt F5. Yes, so here you can watch. Yes, so that is a 2D array index we have to print. Yes, and here if you not provide slash n, so every one row that taking means that, and here now I get ch. So that is a 2D array. You can also print metric format, yes, in so many definition, yes. So look, yes, now we can provide one slash n in our message. Okay, so that perfectly print in with index. First technique, yes, you have to know very well. That is we have to always use. Now we can start our number of techniques. So here first I print the index, and that first technique you have to know very well. Now we can start to different type of technique. So here we can take first p and ampersand x of 00, that address. So we can take number of technique, and then again here I copy, yes, so all this part and paste to here after. So we can different means taking the different. So yes, in you have to know in my 1D array with pointer session. So here I just give the reference. So what is here? I also write paperwork. X of I, yes, here X of I, that is 1D array, and that internal full form is a asterisk, means that value X is a base address plus I. So that is a full form of this technique. Yes, I think you have to know very well. So what is a full form of X of I and J? So that we can also print. Yes. So here I give again that is a X of I first, then same, and then plus J we can explain is expand that formula, and then asterisk. So that is also print the same element. Yes. That is a perfectly work. Yes, let us check. So that is a first technique. So that is a pointer. Yes, here first we can one index solve, means explanation of this formula. So based on this we can column expand. So x first subscript remaining same, and plus j and parenthesis, and before the asterisk, that meaning the that value, refer that value. So that is a equal statement, this statement and this statement. And then again that I give the second technique. So both index means subscript we can expand. So what is a solution? So yes, here first I asterisk, then we can expand x plus I. Yes, you have to look. Yes, first over this technique or 1D array. Yes, we can expand this. So yes, then plus j, and then that subscript. So that is a second parenthesis, and then so that is a now exact explain internal solution this formula, that x of ij is in internal expand this statement, so that value is printed. Because 2D or 1D array is a working, internal is a pointer, and pointer work in the array and pointer co-related very concept in C language. So yes, we can expand also. So we can also print this statement. This there are two technique, and then here you can after or before there is no any here we can write like again this statement equal to this statement. Why? So here like I asterisk, and then you can explanation before or after, there is no difference. So there is a next technique we can say that. So you can like in I outside of subscript and x and then j. So that is a equal statement, and then equal statement asterisk, then same our technique again asterisk and then parenthesis I first and then x. So in math rules you can before the plus and after there is no that statement is changed, so that is a same statement. So we can explain the four technique, yes, here. So that is a first you can print your element today, that is a that equivalent statement. So here we can I outside and x in subscript because that explanation is a this. So here before or after there is no meaning change or plus sign. So here we can first x and then I, or first I and then x. There is no change. So that is a plus means addition operation. And then our pointer asterisk p. So that is a, and then our formula, yes, that is formula. So we can print in 8 technique. Yes, now I remove this all because we can just explain. I all write in our printf statement. So yes, I remove these all parts, means our paperwork. So yes, I also write in our printf means statement. So we can first 5 technique I here use in first here. So yes, let us check how, and here yes we can print also index. There is no problem. So the yes here we can write first our technique and asterisk parenthesis x of I then plus j, that is a first, yes, and that percentage d, and we can tab so that 5 gap and then second percentage d. Again I explained to you in previously, so expand all statements, so parentheses, then here asterisk, then parenthesis x plus I, then parenthesis plus j. Okay, so that is a now complete. Okay, so that is a second technique. Now I give again slash t and according to percentage d here third. So that we can already before and after. So that asterisk and then I outside and x inside in subscript and then plus j and then parenthesis. So that is a now third technique. Yes, and slash t percentage d. Yes, again I expand them same. Yes, here asterisk inside the asterisk and then parenthesis x plus I and then plus j. But here we can take the first I and then x. So that is a explanation of this full form. We can write just x and first x and then I, and here I and plus x. So that is same. So 4 and last here means that 5 and that our here is a 6 technique. So yes, now 2 is remaining. 8 technique we can print. Okay. So here I slash t. Yes, I, and then again yes percentage d. So there is 5. Yes, percentage d. So what is remaining? So asterisk p our pointer itself. Asterisk p. So here we can plus plus. Yes, that is a jumping. So p plus plus. So then and then our value is print. So that is a taking first base address and then according to that jumping that scale factor and print our element. Okay, so let us take first 6 technique. So here you have to know that x of ij. Now here that explanation expand of this internal statement. First one subscript we can expand, then 2 subscript we can expand. So 2 asterisk sign. Here is only 1 asterisk sign, and then in subscript x and I outside. So that is a same statement here, and then of both I before, that is explanation of this statement, this formula to this formula explanation. So 2 asterisk sign I plus x, here x plus I, so here I plus x and then asterisk. Yes, I think you have to know very well. So let us take that print perfectly or not. Yes, there is no any error. So let us take, yes, so but here our subscript and all slash t, so that is so long, so we can not give the slash t, otherwise all one solution is there, we can remove our index. There are 2 solutions. So yes, here I give only 2 byte gap, so we can print also index. So here not give the slash t. So 2, I give the blank to ourselves. So let us check. Otherwise, we can also remove the index because we can already print the index. Yes. So look, that is a 1, 2, 3, 4. Okay. So yes, that is a 1, 2, 3, 4, 5. Yes, 5 is there. So here 2. Yes, 1. Then gap is there. So after, yes, here we can one blank. So that, and you can also remove the index. Yes. So one our previously technique x of ij and here 5. So 6 technique we have to already print, and now that is 2 is remaining. So there are 8 techniques. Yes, first I my statement and write a program to print 2D array using pointer. There are 8 techniques, 8 way you can say that. So now we can use this formula. Yes, here that formula. So we can also print the element. So again I copy these all things. Yes, and just here all the things. So here also that p plus plus, so that address is jumping, so we can assign to for address. And now you can also use like that taking directly x, that array name. Let us check. And here not p plus plus or formula, and that time I not use the index. Yes, I not print only, and that metric format we can print. Yes, so let us check. So only 1% D, and then our formula. Yes, so what is our formula? So that is a asterisk, and we can use the P. Yes, P or pointer variable, plus that is a uh, row number. So that is row number is our I. Yes, and then multiplication sign. Yes, you have to know. And total number of column. Yes, that is total number of column. Yes, 3. And then column number. So that is a J. Yes, I think you have to know very well. Here our formula is there. So look here, base address, that taking the P. Yes, plus sign, row number, that is I, multiplication sign. Yes, number of columns, so that is a column is 3, 3 by 3 matrix. And column number, yes, that is different. Number of column is total column, and column number means that we have to pass to our J variable. So that is a change, and every element is print. So yes, and let us take here, we can give in metric format. So here you have to know in my technique. So symmetric metric, null metric, and addition, multiplication. Yes, I so many definition in my YouTube channel. You can watch metric, that programming metric, all that sum in mathematical. We can convert in our C programming, symmetric metric or not. Yes, multiplication of two-dimensional metric. 2D array is known as a metric array. Yes, that is. So yes, let us check that formula is work or not. So here, yes, I repeat. So that is a P for base address. We can take here base address. Yes, here why we can take again. So here P is plus plus. So that is a last element. So we can take first element again. We can play one music and revert means playback. So that type of that meaning. So here all element is printing and cursor is last position. So we can take first position to our 2D array. So that is assigned to again to base address. Yes, that is meaning. So yes, here base address plus sign, column number, that is column number, we can, that is our row, that column, no, row number. Yes, that is our I is a row, and multiplication column, total number of column is 3, and then column number. Yes, here plus sign. Yes, here I think not comma is there. So here plus sign. Yes, otherwise not print perfectly. Yes, plus not comma. Yes, plus sign. So based on this formula, we can print the seventh technique. That is, yes, here that is giving warning, no any error. Let us check that print. Yes, perfectly print. So that is giving the warning. So yes, that we can use one by one. So here I give ampersand and then 0. That is, I think, also give the warning. Yes, same suspicion pointer conversion. So x ampersand or x of 0. Yes, that is also, let us check this second technique. And here third technique. Yes, here we can use this first technique assigned to pointer variable. address of means pointer variable, that is second, and previously we can give only x, yes, here. So now I ampersand and then 0 1 subscript. So that is third technique, yes. So that is also suspension pointer warning, not error. So let us, that is a seventh technique, yes, no any error. And now here what to do? So I remove all this, and here we can provide the asterisk sign, yes, ampersand is not required. So look here, I give the three technique I already provided, yes, here. And fourth is a like can p equal to x, yes, that fourth. So that is a fourth we can all apply. But in T technique that giving the warning, yes, let us take, yes, here is not warning. So two technique give the warning and two technique not give the warning. So here no any warning, yes, and here any no warning. But on our previous ampersand and x of 0, that taking the warning, not error, yes, warning, suspicion pointer conversion. Yes, this technique giving the warning, and x we have to assign directly at our base address. So that is also taking the warning, suspicion pointer. So there are two technique taking the warning and two technique no any warning. So that is a better. Yes, we can use this type of technique. So the what is the meaning? The base address of taking the asterisk sign. So that is a value, means that pointer assign always address, not value. But asterisk one asterisk. So that is a meaning of first 1D array base address. That is a meaning. So yes, and now last technique 8, I copy again this all, and we can take the last or 8 technique, yes, and see our output. Yes, all are well. So yes, here we can provide the slash n, and here what to do? So we can just plus and minus, here there is no change. So that is a base address and total number of column. Yes, here 3, here 3, and then here you can I and plus, yes, thus shifting our formula exactly. That is a base address, then plus sign, and then a row number and multiplication sign, multiplication, and total number of column plus and uh, column column number. So here we can take column number first, base address plus total number of column multiplication, row number and plus column number. So we can easily identify row number and column number and total number of column. Yes, so that is same formula, but I changed some that formula. So that is also print the same our require element. And yes, here let us check. Otherwise, here we can also shifting our pointer, because here pointer is a plus plus. So if that print garbage value, so we can take the forward. Yes, that no any require. Yes, that directly start, because we can start again initialize I 0 and j is 0. So that not require, and that is taking directly that base pointer. Yes, so that is a eighth technique you can look. First, our previously technique in 2D array element are with index, and then we can provide the 5 technique. So that is a 6 and 2 our metric format 2D array. So that is a based on the formula. So that is also, that is a in that is also one formula. All are these formula you can look, but explanation of x of ij. So here first one subscript explanation, then two subscript explanation internal. So internal array 2D array work, and array is a working pointer. Yes, and array and pointer is a we can say that correlated concept. So array without pointer and pointer without array, you cannot understand both concept. So you can must be pointer and array with a very coordination. It's understanding both same way. So array work in pointer internal in memory, and pointer work in array internal memory. So that is a correlated concept. And array without pointer and pointer without array, you can not understand perfect concept. So half part of array and half part of uh, pointer, that is complete your concept. That is a very important concept, and pointer is a powerful tools of C language. Yes, and that is a hacking. In hacking programming that use the tools is very powerful. That directly, indirectly take your value without condition check, that take your value. So very dangerous use of pointer in uh, that type of program, hacking program. Okay, so you can understand, yes, I expand so many techniques and all formulas. So that is a paperwork, how the jumping of pointer in 2D array. So here there are directly 1D array. So 2D array is a collection of 1D array. Yes, I just show this comment line so you can expand. So here you can watch. So here p equal to x to our first bed array, and then p plus 1 that directly in second our 2D 1D array. So 2D array is a collection of 1D array, and then p plus 2. So p plus 2. So here directly third our 1D array. So 2D array is a collection of 1D array. So we can here's explanation. I summarize all things, and you how that formula that is p plus plus, and individual element you can also print based on this formula, and also we can print. Yes. So here I complete my session. So very interesting session for your knowledge. So how pointer and 2D array work, and you can also scan. Yes, here no need to scan because we can just expand how many techniques. That is my goal of this session. So yes, here we can say that now here four technique to taking the 2D array address, but two is a very important. First I write these two. Yes, that is no any give the warning, but these two give the warning. Yes, so I write in the last. So I my recommendation. So you can use these two techniques to taking your pointer 2D array pointer to assign to address. Okay, so 2D array address, that base address, you can assign these two techniques. And 8 technique you can print our 2D array. So 1D array is a 9 technique and 2D array is an 8, one less. So yes, here I expand that is first x of ij, then our explanation I all revise. So here that is first one subscript full form explanation in internal, then two subscript explanation internal, and then first that is I taking outside subscript and that full form. Yes, so maths rules that is we can apply. So plus x or I, that is no different. First you can x plus I or I plus x, that both happening same thing. So that rules math we can advantage, and taking these two formula using the maths rules. Yes, we can apply the maths rules. So before or after plus sign, you can change your operand, means variable, that no meaning change that statement. And here pointer itself, and pointer you can plus here, not in the row, column. So every column is print perfectly, p plus plus. So 2 byte is shifting, not so here we can say that pointer directly jump in one 2D array to second 1D array in collection of that 1D array, that is second 1D array and third 1D array. So here base address to here and here directly jump. But in that situation, only plus plus in row second inner loop. So that is only 2 byte shifting. Yes, here 2 byte only jumping. And here is that 1D array directly taking to next 1D array. So 2D array is a collection of 1D array. And that is our understanding row and column. Internal no any row, and that is continuous allocation of memory 1D array or 2D array or multi-dimensional array. Yes, and then now our formula. So that is a base address. Then we can say that I means row number, then total number of column and column number. Yes, and here we can just shift to base address, total number of column, multiplication sign, row number and column number, I plus j. Yes, so now I expand all and summarize all these things. So yes, write all these things to your note and understand to yourself. So very interesting, and you can apply to your means this formula and some paperwork to yourself, and then now you can apply any definition like 2D array, metric multiplication, symmetric metric, inverse metric, so many metric programming, and ascending, descending, even odd number, yes, minimum, maximum value, so many definition is there. So yes, write this program to your C notebooks, very interesting. Yes, and here our all, yes, here that yes. So now I close this session. Yes, and alter F3 function key and quit. So yes, subscribe my channel Ashok Sijalakadi, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture. And any doubt for this 2D array with pointer, you can write in comment section. I give the definitely to answer you. Thanks again and Hare Krishna.